So hello everyone, welcome to this series I'm titling Friday Night Physics. This is the first episode, and today it's just to set the structure of how the series will go, and yeah. And so I plan to do this for at least the entire summer, but I'll upload weekly, hence the name. And this is going to be mostly problem-solving based. So basically, first I'm just going to state the basic prerequisites that you should know, but I'm not going to go super in-depth into them. And if you don't know these basic prerequisites, I recommend you go to Khan Academy or read a physics textbook or something. And this is going to be getting problems from the FNet equals MA competition, and it's kind of like a preparation thing for that. And it also helps with my understanding of physics as well. So let's get started with the first episode. So today I wanted to go over one of the more basic parts of physics, which is just basic dynamics, and more specifically in this example, inclines and problems involving them. And so the prerequisites you should know are Newton's 3 laws, and that should be quite basic. So it's just law of inertia, F net equals ma, and every action has equal opposite reaction. And then you should know how to basic kinematic, the 3 kinematic equations, and dynamics. And you should also know how to draw free body diagrams, since drawing free body diagrams, in my opinion, is a pretty core concept of dynamics in general, since it allows you to see all different forces accurately and helps you know which ones are in opposite directions, which ones cancel each other out, etc. So yeah, this is just the basic prerequisites that you should know. And so today is going to be a short episode. There's only going to be 3 problems, but in the future I expect to be like at least 6 problems per episode. But yeah. So the first problem says, a 100 kilogram object on a slope of 30 degrees is at the bottom of the slope, and the length of the slope is 5 meters, and the object is pushed up the slope with a force of 1,000 newtons. And the friction force is 400 newtons, and we want to find the velocity at the top of the slope. So that's just V final. And that's what we want to find. And so, first, as with every problem involving dynamics, you want to draw a free body diagram first. So for this example, let's draw a free body diagram. And so you have the force of gravity, and you can split the force of gravity into 2 components. And this angle is 30 degrees. And you have the normal force, which is given to the block by the incline. And you have the friction force. And we have the force that is used to push it upwards. And the force of gravity is going to be equal to m times g, and that's just equal to 1,000. Since, well, remember in Fnet equals ma, g, the force of the acceleration of gravity, will always be 10 meters per second squared. And you split this into components. I know that this horizontal component will be 1,000 times sine 30 degrees, which is 500 newtons. And then we know that the y component, which is 1,000 times cosine 30 degrees, and the force of the normal force will cancel each other out, so we can just ignore it. So the net force is this, which is 1,000, minus the friction force, which acts in the opposite direction, minus the horizontal component of gravity, which is 500, which is equal to 100 newtons. And the second law of Newton states that the net force, which in this case is 100, is going to be equal to the mass, which is also 100, times acceleration. And so now we know that acceleration is equal to 1 meters per second squared. And now that we know that, and we also know the length of the slope, we can apply the basic kinematic equations to find the final velocity. So we know that v final squared is going to be equal to v initial squared, and v initial is just 0, and it's going to be equal to 2 times a times x, which is equal to 10. So we have v final is going to be equal to square root 10 meters per second. And that's the answer. And again, the concepts here are quite basic. It's just basic dynamics and kinematics. Next, we have problem 2, which is also very similar. Again, you have an incline, and again, this is 30 degrees. So most f net equals ma problems, the angle will be 30 degrees, since sine 30 degrees is 1/2. So in this case, the block is on top of the incline, and the length of the incline is 10 meters, and we know that the block has mass m, and the static friction on the slope, so mu of s, is equal to 0.15, and the kinetic friction, mu k, is equal to 0.1. And we want to find the energy lost to friction. So again, for this problem, you want to draw a free body diagram. So again, you have the force of gravity, you have the normal force, and you have the force of friction. So in this case, again, you split the gravity into its two components. The horizontal component is going to be equal to mg times sine 30 degrees, and then we know that the friction force is going to be equal to the normal force times the coefficient of friction. So the normal force is mg cosine 30 degrees times the coefficient of friction, which is 0.1. And so we know that it's going to be able to slide down. So the energy lost to friction is just going to be equal to the work that friction does. And this isn't related to dynamics and kinematics, but basically work is equal to force times distance. And we know the force is mg cosine 30 degrees times 0.1, and the distance is 10. And then we can use g is equal to 10. So then we have 5√3m joules as the amount of energy lost to friction. So the next problem is also very similar. Again, it's on a slope. So again, we have a block on a slope. And we have that it has initial velocity v0, and it moves to the top of the, well, not necessarily the top of the incline, but as far as it can before it stops at rest, and it slides all the way back down. And we want to find the time to u, the ratio of the time it takes to go up the slope to the ratio of time it takes to go down the slope. And so again, for this problem, we can just use basic kinematics and dynamics. So again, we draw a free body diagram. and we know that it has a coefficient of friction 0.5. And we know that the length of the slope is L, and the height of the slope is 0.6 L. So after we draw our free body diagram, we know that we have the friction force and the force of gravity, and yeah, and we have this is theta, and we know that sine theta is going to be equal to sine of theta is going to be equal to 3 over 5. Since just Pythagorean equation, the side is 0.8 L, and we know that cosine of theta will be equal to 4 over 5. And so using this, we can find that the net force on the block at the bottom is going to be negative mg, so the acceleration is negative g. And using basic kinematics, we can find that the time it takes will be v0 divided by g to go up. And then we can use the equation v final squared is equal to v initial squared plus 2 times acceleration times distance to find that the distance or displacement is equal to v initial squared divided by 2g. And we can use this to find the time it takes to go down the slope again. And we can find that the final velocity when it goes down the slope is square root of 5 over 5 v0. And so since the velocity and time are proportional, the ratio of time is just going to be square root 5 over 5. And that's the final answer. And so yeah, that's it for this video. Thanks for watching. Consider liking and subscribing.